All right, Unit 3, Day 19 notes, Part 3. Uh, this next part is going to be all these practice problems here on page 2 of the notes. Why don't you go through and try using the product rule, and then check first the answer. I'll do two at a time, and then I'll have you check them. All right, good. Okay, so here's the first two. And just make sure on the second one we change the square root of x to x to the 1/2. And again, what's the product rule say? Product rule says take the derivative of the first times the second function, add that to the first function times the derivative of the second function. Now, this one right here could also be written with radicals. We don't, again, just get it to a positive exponent. Give me a second, let me write this down. Okay, so I could write it with radicals, change it from the rational exponents to here, but what I circled here would be fine also. Okay, so keep working, try the next two. Okay, check what you have on the next two. And again, notice in the first one for f of x, we found the derivative. They had a like term, and I factored that out, the x squared. Okay, and then here I distributed the negative sign x. So once we get it, we want to try to simplify it as much as possible. Okay, let's move on to the next two. For this next one, it's just like two parts. So when I take the derivative of 3 theta is just 3. But now, here, for the theta sine theta, now I got to do this. Hey, what's the derivative of theta? That's just going to be 1. What's the derivative? Derivative of theta times the second function sine theta plus just the original theta. And now the derivative of sine theta is cosine theta. I would just clean it up a little bit, simplify, but it's for the most part simplified. So we get 3 plus sine theta plus theta cosine theta. And that's our final answer. Okay, the second one, we get cosine squared x minus sine squared x. And I know some of you quickly thought, oh, maybe that's 1. Nope, that's sine squared plus cosine. This is not that. And there's another way we could write this. So what I could do is I know, oh, that's cosine squared x minus sine squared x, and I know sine squared x is equivalent to 1 minus cosine squared, and I'm going to simplify this. Again, that second way is based on the fact that sine squared equals 1 minus cosine squared, and so the derivative could also be written as 2 cosine squared x minus 1. Those give you the same thing. Okay, so let's do this last example. To find the equation of the line tangent to the graph of g of t, which is equal to t squared cosine t, and we're going to find when t equals pi over 6. So first thing I need to do is find the derivative. Once I find the derivative, I can substitute in pi over 6, and that'll give me what the slope is right then and there. And then I can find the point of tangency, and that'll give me the equation. So it's going to be a couple steps here. First thing we do is use the product rule to find the derivative. Then simplifying gives us this. Now let's find the value of the derivative when t equals pi over 6, and that'll give us the slope of the tangent line. Okay, so now we're going to simplify 2 times pi over 6 is pi over 3. Cosine of pi over 6 is in the first quadrant, so it's going to be positive. Square root of 3 over 2. Pi over 6 squared is going to be pi squared over 36. And sine of pi over 6 is going to be 1/2. Let's simplify this again and find a common denominator. All right, so I found the slope of the tangent at pi over 6 to be 12 pi times square root of 3 minus pi squared over 72. Now I need to find the point of tangency. How am I going to find that? I'm going to go back to my original function, and I'm going to substitute in pi over 6. So let's do. So substitute in, we get when x is pi over 6, y is pi squared square root of 3 all over 72. So let's now use what we know about point slope equation of a line to come up with that equation. Okay, and the only new part of this problem was just using the product rule. Everything else, we've done the process. Obviously not the same numbers we found in Algebra 1 and Algebra 2, but all stuff we can do. All right, so that's the end of part 3. Let's go on to part 4 coming up.